Hello and welcome back with Mrs. Struble. Today we're going to be talking about evaluating expressions. First thing we're going to do is we're going to go into how we would evaluate simple expressions involving exponents. And then what about more difficult expressions? How would we use our order of operations in order to evaluate those? And finally, our ultimate goal here is being able to substitute into algebraic expressions in order to evaluate them. Okay, so let's go ahead and get started. First, let's talk about evaluating exponents. Now, exponents are set up looking like this. There's a big number and then just a little what we call subscript value up here. This number right here is the actual exponent, and the big value is what we call the base. An exponent tells us how many bases we have. Okay? And then we're going to use that knowledge and we're just going to multiply all of those bases together. For example, I have 2 to the third power. 2 is our base and 3 is our exponent. Our exponent tells us how many bases there are. So this says there are 3 2's. So we can go ahead and write down 1, 2, 3 2's. Once we've done that, we need to multiply them together. So we're literally going to take 2 times 2, which is 4, times 2 one more time to get our answer of 8. Here we have 3 to the third power. So again, this is telling us that there are 3 3's now. Okay, so we're going to literally write 1, 2, 3 3's. And what are we doing with those? We are multiplying them together. When we multiply, we can really only multiply 2 numbers at a time. So 3 times 3 first, that gives us 9. And then we bring that other 3 down. 9 times 3 gives us our final answer of 27. Okay. That's the basic idea of exponents. However, exponents can also have parentheses, and we need to be very careful of where those parentheses are. The placement is very important. So here we have 3 different expressions using those parentheses with exponents, and as you can see, there is a slight difference in each of these, and we'll find out that makes a big difference when it comes time to evaluate them. So let's start off with the first one. Okay? I like to say this little phrase. The exponent takes only what is right in front of it, okay? Or immediately in front. So this 4 right here is taking the parentheses, and it's saying that everything in the parentheses is our base. Okay, so there are 4 negative 2's, because negative 2 is the entire thing that's in the parentheses. So we're going to write negative 2 4 times. Okay, an exponent tells us how many. There are 4 of them. And now we're going to multiply them all together. Negative 2 times negative 2. A negative times a negative is a positive. 2 times 2 is 4. Bring the rest of it down. And again, I can only do 2 numbers at a time. So 4 times negative 2 is negative 8. Times it by negative 2 one more time. Negative 8 times negative 2, we get an answer of 16. Okay. In this second example, the exponent is here inside the parentheses. where the negative is on the outside. So let's start with that exponent. The exponent takes the item immediately in front of it, and that only. So this 4 is saying that there are 4 2's, because 2 is the only value, only thing in front of it. So we're going to write the 4 2's, 1, 2, 3, 4, and we're going to multiply those 4 2's together. So what happens with this guy? He just kind of falls down. He tags along for the ride, okay? He falls down. He's right here, okay? So everything else kind of just falls down. So now we have negative 2 times 2 times 2 times 2. Two numbers at a time. We have negative 2 times 2, negative 4. Copy everything else down that we didn't use. Okay. And repeat the process. Negative 8 times 2. We get our final answer of negative 16. Okay. And if you notice, we create kind of what's called, or what we like to call a funnel look. Okay. We start off with a lot of operations, and then we are slowly undoing or getting rid of, or completing rather, one operation at a time so that we can derive at one final answer. So that's what it looks like in a funnel. As you can see, these are completely opposites right now. Okay, let's take a look at this third option. What if everything was inside the parentheses? The exponent, the base, and that negative, all inside those parentheses. Well, the exponent takes the item immediately in front of it. So what is immediately in front of it? The 2. Then the question becomes, does the negative go with it or not? And the answer is no. The negative this is not a negative, or a negative 2 repeated 4 times. This is one negative with 4 2's. Okay? The negative is not attached to the 2 strongly enough for it to go together. Here's why. I can just input a 1 and say this is the same as negative 1 times 2 to the 4th. Because anytime we multiply by a 1, we just get that other number. Okay? So the 1 just kind of disappears. It's understood to be there, but we don't really write it all the time. So taking the 2, we have that appear 4 times, exponent of 4. 1, 2, 3, and I'm going to move back over here, 4. Okay, and the negative just kind of falls down again. All right. Now, as soon as we do that, then we realize, oh, this looks very similar to this one right here, this first step. And it is. Okay. So we're going to get the same answer there, here, as what we got there. Okay. So negative 2 times 2, that's negative 4. Bring everything else down. Get in the habit of bringing everything else down. Don't get lazy with these. Because the more difficult these expressions are, the more important it's going to be for you to actually rewrite everything or drop everything down that we didn't use. Okay? All right, so now we have negative 4 times 2. That leads us to negative 8. And then we got that one more 2 that falls down. We didn't touch him, so we got to include him. And then we got negative 8 times 2, and that is how we once again get negative 16. All right, so there's the difference between where the placement of the parentheses are and how important it is. You can end up with the total opposite of the actual answer. So we need to pay close attention and just remember this. Exponents take only what is immediately or right in front of them, okay? All right, so there's our exponents. Now, how do we pull this all together to evaluate expressions? We have to use the order of operations. You may have learned it as PEMDAS, okay? Please excuse my dear Aunt Sally. It's an acronym for an algorithm or a step-by-step process that we use in order to evaluate any expression. Okay? So first we're going to deal with parentheses, and we're going to make sure that there is only one number inside the parentheses before we move on to the next step. As soon as that is done, then we can complete or evaluate any exponential terms in the expression here. Okay, so in other words, we're going to evaluate any exponents we see. Then we'll take care of multiplication and division, but we need to do this from left to right, as if we're reading a book. Okay? It's not multiplication first and then division. It is literally reading it from left to right. We're going to take care of all of them, multiplication and division. Same thing with addition and subtraction as our last step, left to right. All right. So here we have an example. We see parentheses, but there's only one number inside, so P is done. Exponents. Here is an exponent. What is in front of that exponent? We have the parentheses. So this is telling us that there are 3 -4s. We're going to write them down. 1, 2, 3. Okay. We're going to end up multiplying those -4s together. We got to finish up this exponent here. Okay. Right. So -4 times -4 is +16. Times it by -4 one more time. That's going to give us -64. Now we have to go back. Okay, we evaluated the exponent, but what is left? I still have a negative right here that we did not touch. So we have to have that negative still there. Okay. So we're going to put him down. What else? Well, we have a -5 times 8. Okay. So now we have this new expression. We're slowly getting rid of one thing at a time. Okay. Exponents are gone. Parentheses only has one number in it. We're moving on to multiplication and division. From left to right, well, we only see one multiplication and division problem. So that's where we're going to do what we're going to do. -5 times 8. Negative times a positive is a negative. 5 times 8, 40. Everything else falls down. Okay. The only thing that's left is this subtraction. Now remember, when we subtract integers, we keep change, or we just remember that subtracting is the same thing as adding the opposite value. Okay. So we have -40 plus 64. We're going to end up with 24. A lot of work, I know, but we really got to make sure we write this all down. The simplest mistake, not writing down a negative sign, can lead us to a very incorrect answer. All right, let's do one more. Okay. And just a key side note here, make sure you are underlining which step you're doing. So as I do this, I'm underlining exactly the one operation that I'm focusing on for that next line. Okay. Take it one step at a time. Make sure you create that funnel shape in order to derive the correct answers. Okay. So we have 3 plus 7 times negative 3 squared. All that divided by 5. Okay. Using PEMDAS, parentheses, well, we have an exponent inside. That's all we have. So we have to evaluate this exponent inside the parentheses. The 2 says that there are 2 3's. The negative is not attached. So we're going to write down those 2 3's. Okay. And multiply them. So negative 3 times 3, they're still inside the parentheses, is going to give us negative 9. Okay? So this is the same thing as saying negative 9. That's the one we did. Okay, so underline it. There it is. Now let's do that next step. We've got one number inside the parentheses, but we also took care of our exponents at the same time. Next step is multiplication and division from left to right. I see a multiplication here. So that tells us that we're going to do 7 times negative 9 first. And 7 times negative 9 is going to be negative 63. And then everything else needs to fall down exactly where it was. Okay? So there was a 3 in front of here. You can do the plus sign, that was there. And then we have negative 5 in the denominator. Okay? Now in this case, you have to view the negative 5 as a denominator. What this is basically telling us is, hey, take all of this and divide whatever you get by 5. Okay, so we have to solve this top first. We have to solve the numerator first. So 3 plus negative 63. Different signs, we take the difference. 63 minus 3 is going to give us 60. We have more negatives than we have positives. So this is going to be negative 60 divided by or over negative 5. Okay. That's the step we did right there. And we got negative 60. So negative 60 divided by negative 5, negative divided by a negative is a positive, and we get 12. Okay. All right, here we go. Now let's talk quickly about substituting values. When we have algebraic expressions, we can evaluate them if we are given the values for each variable or each letter, okay? If I know what each letter stands for, then I can find one number to represent the entire expression. And the fun phrase I use here is whenever you see the variable, you replace it with the given value. So if I tell you in this example that x is equal to negative 2, wherever you see an x, put a negative 2. Okay, they're interchangeable. So everywhere I see an x, I'm going to put a negative 2 instead. Just like that. Okay? We need to make sure we understand what's going on here, though. Okay? If I tell you 5y z squared, what that means is we're taking 5 times y times z, and the z is squared. Okay? So even if you want to write it out a little longer and put those multiplication signs in there, please do so. So now we're going to do what's called substitution. And we already did that here with this x. Any variable or letter, we're going to replace it with the value or number that they tell us it is. So y is equal to negative 1. Everywhere we see a y, we're going to put a negative 1. I see a y right here. I'm going to put a negative 1. Okay. So now we have 5 times negative 1 Now z. Okay. Z is equal to 3. Well, I see a z right here. I'm going to put a 3 right there. Z, or 3 squared, all of that over -2. Okay. From here, we just use PEMDAS, or order of operations. Again, we have a whole bunch of numbers in the numerator. We need to pretend that there's parentheses around there. Okay. Take care of those exponents first. Inside the parentheses, we're working inside the parentheses now. So 3 squared is 3 times 3, which is 9. Now we have 5 times -1 times 9. 5 times -1 is -5. -5 times 9 is -45. And this 2 just kind of tags along. Hey, I'm still here, is what he's saying. Okay? So now we're going to take -45 and divide that by 2. We get a positive 22.5. Do not be afraid of those decimals. Okay? How many 2's are in 45? Well, there's 2 2's in 4. There's 2 2's in 5 with 1 left over. Okay? So that becomes a decimal right here, and we get 5. All right, here we go. Let's do another one. Again, our first step is to make sure we're substituting. Everywhere I see an x, I'm going to put a -1. Oh, x, ding, x, ding. And then everywhere I see a y, I'm going to put a 4. And remember that in between are multiplication signs. Okay? This is multiplication in between here and here. Okay, let's rewrite it so we can see what we got. We have a -1. The -1, the x, is what is being squared. Okay, so sometimes it might even help to put parentheses there when there's a negative involved. Timesing it by 4 plus -1, and then y is going to be squared, so that's going to be times 4 squared. Okay, here's our expression. Let's go ahead and break it down. Take care of those exponents first. This 2 is taking the whole parentheses, which is -1. So -1 times -1, that's going to be just 1. This parentheses over here, or excuse me, this exponent is taking the 4. So 4 times 4, that's going to be 16. Everything else falls down. We don't touch it. We didn't do anything. Okay? We just took care of those exponents. So the exponents are now gone. Drop everything else that we didn't touch down. Okay, even these little signs, you see that? All right, now let's keep going. We got to do multiplication from left to right. I don't see any division, so we're good there. We've got this multiplication, -1 times 4, that's going to be -4. Drop everything else down. Okay. There's another multiplication problem right here. There's a multiplication sign right here. So we have -1 times 16. That's -16. And everything else drops down. If I did not do anything with it, I didn't underline it, I'm not doing anything, I have to drop it down so that I don't forget about it. It's still there. All right, now we're just left with -4 plus -16. They're both negatives, so same signs, we're just going to add those absolute values. We get 20, and they're both negatives, so we stay negative. -20. Okay? All right. Now that we've talked about exponents, we've talked about using order of operations, we've talked about substitution, we're going to throw it all together. We're going to throw this all together and let you give it a shot. So go ahead and pause the video and give these problems a try. You're evaluating each expression when x is 30, y is -3, and z is -2. Try them, pause it, I'll be back with the answers. You've tried them, here are your answers. Again, make sure you're showing your work. Okay. We got -5, 9, -2, -9. Number 24 here, that was actually 16.5. If you left it as 33 halves, that's okay. It's just what we call improper. There's nothing wrong with it other than that. And then number 25 is 5. Okay, so the trick in all of these is just follow those steps and make sure it's simplified in the end. Thanks for joining me as we dove into this lengthy discussion of how we would evaluate expressions, whether we're using substitution, exponents, or just in basic integers, okay, using the order of operations PEMDAS. So until next time, thanks for joining me.